Okay, guys, so now we're going to talk about terminal voltage. Okay. Usually what happens is, okay, you have a battery, and the battery has a little bit of internal resistance. It's smaller, it's super small, but there is a little bit of internal resistance. So even though this battery is, let's say, rated at 5 volts, the voltage that will come out of the terminal of the battery, let's say these are the terminals right here, it's not going to be full 5 volts because there's going to be a little bit of voltage dropping due to the internal resistance. And the internal resistance is usually shown as a small r, okay, because it's very minor, small value. So the voltage that actually comes out of the terminal is not going to be 5 volts, it's going to be a little bit less than that. So let's have a look at a simple example. Okay, let's say this battery is connected to a resistor, okay, and then we have this circuit, and let's say this is our 2 ohm or 1 ohm resistor. Let's say this is our 1 ohm resistor, okay. Now, let's say this resistance right here is 0.2 ohms. So folks, the first thing what you would do is you would find the total resistance. A total resistance, because they are in a series, it's going to be 1 plus the internal resistance, which will make it 1.2 ohms. My voltage total is 5 volts. So what's my current going to be? So the first thing we're going to do is we're going to find our total current. That's going to be voltage total over resistance total, which is going to be 5 divided by 1.2. 5 divided by 1.2, which gives me 4.17 amps. Okay, now that I know my total current, I know how much current is going to flow here. It will be 4.17 amps. And the same current is going to flow over here, 4.17. Again, there's going to be a little bit of discrepancy in rounding, okay? Now, if you do 4.17 times 0.2, how much does that give you? That gives me 0.834 volts. That means the voltage drop across this internal resistance is 0.83 volts. Okay. What that means is that the terminal voltage is going to be my total voltage minus the voltage drop across this internal resistance, which is I times R. This is the voltage drop in the internal resistance, which is going to be 5 minus 0.834 volts. Okay. And how much is that? 5 minus that gives you 4.17 volts. So there we go, folks. Even though the battery was listed, it was rated at 5 volts, the actual voltage that comes out is only 4.17 volts. And you can see how much voltage is going to, how many volts are going to drop over here? 4.17 times 1, which is 4.17. Okay? Which is exactly equal to your terminal voltage in this case. So that's how you get this formula. That's how you get this formula. The terminal voltage is your total battery voltage minus IR, where R is the internal resistance. So essentially, this is telling you whatever the voltage drops inside the battery, you're going to subtract that from the rated voltage, and that's the terminal voltage that gets applied to the rest of the circuit. Okay, so now let's have a look at this question. The question says you have a 6-volt battery that is connected to a 100 ohms resistor. So we have a battery, and this is 6 volts. It's connected to a 100 ohms resistor. So we have a 100 ohms resistor here. The voltmeter is placed across the resistor. It measures 5.60 volts. So you took a voltmeter across this resistor. And this voltmeter is reading 5.60 volts. What this is reading is the voltage drop across this resistor. Means 5.60 volts have dropped across this resistor. Now they're saying find the internal resistance. So we want to find this internal resistance. Okay. We want to find this internal resistance. So let me just draw this one out. This is your battery right here. Okay. This is the internal resistance that we've drawn, and this is our circuit. So first thing, we know our voltage is 5.60 and this is 100 ohms. So I can get my current here. My current is going to be V over R, right? So 5.60 divided by 100. 5.60 divided by 100 is 0.056. So the current that passes through that resistor is 0.056 amps. That's the same current which is going to pass through this, right? Because it's in the same series. So that's the same current that passes here. Now, this was 6 volts, 5.60 volts dropped here. How much voltage is left? 0.40. So that's the voltage which will drop across this resistor. Now I can find the resistance of that. That will be the voltage drop across that resistor over the current that is going to pass through that resistor, which is 0.056 amps. Okay, so 0.40 divided by 0.056 gives you 7.14 ohms. That is your internal resistance. You see, I didn't have to memorize any formulas. I used pure logic to find that. So now in the next question, they're saying 6 1.50 batteries are connected in series with positive terminal of one battery connected to the negative terminal of the next. Okay, so what's happening is, you see the longer terminal is positive, this is negative. And then you connected it to another battery. This positive terminal, you connected to the negative. This was a positive of that, you connected to another one. And you did that 6 times, okay? Now imagine you did that 6 times. So what's this total voltage going to be? This total voltage is going to be 6 times 1.50 volts. Okay, now what's 6 times 1.50? That is 9 volts. Does that make sense? So first question says, what is the EMF of the combination? If you combine 6 batteries, the EMF is 9 volts, okay, because they're all connected. Now they're saying there's the internal resistance of each battery. It's 2 ohms. Okay, now think about it. Think about where we have 6 2 ohms internal resistors. Now, rather than drawing that, you know, my diagram will look really messy if I do that. So just to simplify that, what I will do is I will just draw one big voltage source, and I'm going to call it 6 times 1.50, which is 9 volts. And then instead of drawing 6 resistors of internal resistance, I will just do 1. And 6 times 2 is 12 ohms. That's your internal resistance. Okay, this right here is my internal resistance. Does that make sense? When you connect the negative, the positive of the battery to the negative, and you keep doing that, you form a battery in series. So think of that as having six batteries all connected together. So it's essentially one big battery of 6 times 1.50 volts. Do you understand that part?
Yes.
Okay. So they're connected. Okay, what is the EMF of the combination? That is 9 volts. If the internal resistance of each battery is 2 ohms, find the terminal voltage when a current of 200 milliamp is passed through the circuit. So there is some resistor. We don't care about what that resistor is because it told me the current that goes through this. It told me that the current that goes through is this 200 milliamps, which is essentially 0.2 amps. So what current goes through this? 0.2 amps. You know the resistor, you know the voltage drop. Okay, what's the voltage drop going to be? 12 times 0.2. 12 times 0.2 gives me 2.4 volts. Okay, so out of 9 volts, 2.4 volts are going to drop within the internal resistance. So what is the terminal voltage going to be? What voltage actually comes out? The terminal voltage will just be 9 minus 2.4. So 9 minus 2.4 gives me 6.6 volts, okay? So after the voltage drop in the internal resistance, the actual voltage that are going to come out is 6.6 volts. And that 6.6 volt is going to be dropped across this resistor. Okay, in the next question, they're saying that 3 12-volt batteries are connected in series. So we can think of it as having one big battery whose voltage is 3 times 12, which is 36 volts. Okay, and they're saying that the internal resistance is 10 ohms, 20 ohms, and 30 ohms. So we can think of them as having, let me write the combined internal resistance. That is going to be 10 plus 20 plus 30, which is 60 ohms. That's your combined internal resistance of this battery, okay? and it's connected to a 35 ohm resistor. So this is your 35 ohm resistor. Okay. Think of this. This is your battery. Okay. This is your battery. So what's my total resistance? My total resistance is my internal resistance plus the resistance of that resistor, which gives me 95 ohms. What's the total voltage? The total voltage is 36 volts. Okay. So from there, we can find the total current. The total current is going to be V total over R total, which is 36 over 95. 36 divided by 95 gives me 0.38 amps. Okay, so I know how many amps flow through here, 0.38 amps, and the same amps are going to flow through here. Now the question says, find the voltage drop across 35 ohm resistor. Very simple, you multiply them. So that multiplied by 0.38 times 35, you get 13.26. 13.26 volts, folks. Okay, that's the voltage that's going to drop across the 35 ohm resistor. Okay, so let me recap that. So whenever you have batteries where a negative and a positive terminal, the positive of the first one is connected to the negative terminal, then you can think of these batteries as being in series. So if this was 10 volts and this was 10 volts, in total now these batteries are giving you 20 volts. But you have to make sure that the positive is connected to the negative. Okay, negative, the positive of this is connected to the negative. Okay, and if you want to add more batteries in series, this positive will need to be connected to the negative. If you want to add more batteries, this positive should be connected to the negative. Okay, and these will keep on adding on. We will have 20 plus 10 plus 10, so 40 volts for that. Okay, that's the concept that they've explained over here. Now, sometimes you will see that their notation is a bit different. Like in this example, look at this. This is a negative. Here's a positive. Now, positive is connected to a negative. Here's a positive. But then over here, we have a positive. Okay, now look at that. This is 30 volts. Means you can imagine it's going to push 30 volts this way. But this is 60 volts. It's going to push 60 volts this way. Because you always go from positive, right? So this bigger one is going to overcome this voltage. The 60 volt is going to overcome the 30 volts. So technically, how much voltage is actually going to flow? The actual voltage flow is going to be 60 minus 30, which is 30 volts to the right. Okay, think of it like that. Okay, so what we will do is I will say my total voltage in this case is going to be 30 volts. Okay, because they're canceling, they're going against each other. Okay, over here they've shown these batteries in parallel and they've shown this resistor. Well, one thing is for sure, if you only have one resistor, what's your total resistance going to be? Whatever that is, which in that case is shown as 3 ohms. And also, whatever the voltage is here, right, there are 3 identical batteries shown in parallel. And you know the parallel voltages should be the same, right? So whatever the voltage is here, is the voltage here, is the voltage here, is going to be the voltage across this resistor, right? So the voltage is going to be whatever the voltage is across each of these batteries. And they're all 9 volts, so the total voltage is 9 volts. So from there, we can find the current total, which is V total over R total, which gives me 3 amps. So we know a total of 3 amps is going to come into this resistor. Okay, now because all of these voltages are the same, that means 1 amp must come through here, 1 amp must come through here, and 1 amp must come through here. Okay, this is how you determine how many amps are going to flow through each of those circuits. Just remember, in parallel, the voltages are the same.